Okay. We're going to title this Covalent Bonding Notes. Okay, so first example, we're going to do a single bond. And the thing to remember is that we have two nonmetals. The example that I'm going to give is carbon and hydrogen. We're going to see how those interact. There's many compounds that carbon and hydrogen can form together. The one that we're going to be interested in today consists of one carbon and 4 hydrogens. The first step is to draw the valence structure. Carbon is an atom that has 4 valence electrons by looking at your periodic table. Hydrogen, on the other hand, is an atom that only has 1 valence electron. Since we have 4 hydrogens, it's going to be pretty simple to see how this is going to end up. This is called carbon tetrachloride, and it ends up looking like this. Carbon here, 4 valences equally distributed among the 4 quadrants, and a hydrogen at each empty spot here. Each of those empty spots, carbon and hydrogen form a single bond by sharing the electrons. So this hydrogen feels full because it's filling the outer shell. It has a single orbit, so it only needs 2 to feel full. The carbon, on the other hand, it's not filling the first orbital. It's filling the second orbital, and it needs 8 to feel satisfied. And you count around here, and the carbon feels as if it has 8 electrons. Let's do one that's a little bit more complicated now. Let's do a double bond. The same principles will apply. And the way I would do this is to look for 2 nonmetals in the periodic table. The ones that I'm going to choose this time are oxygen, 2 oxygens. We're going to make oxygen gas, or O2. Step 1 is to find out the Lewis dot structure. For oxygen, it happens to have 6 electrons in the outer shell. Now, when I draw these electrons, I want to draw it in a way that I kind of look ahead. So I look ahead and realize that I'm going to need a double bond between these 2 oxygen atoms. So I'm looking ahead to try to distribute the electrons strategically, if you will. So this oxygen having 6 electrons, I'm just going to put 2 there, 2 up top, and then 2 over here. The second oxygen, I'm going to draw that here. I'm going to have 2 up top, 2 back on the side here, and then I'm going to have the other 2 over here. Draw those as X's to keep them separate. Now comes an important step. I'm going to go back and I'm going to check. I'm going to check to make sure that both of the oxygens feel full and that they feel like they have 8 electrons. So here we go. I'm going to put a circle around this oxygen and the electrons that it feels like it has. I'm going to count them. There's 1, 2 there, 4, 6, 8. So this oxygen on the right feels like it has 8. Now I'm going to put a circle around the other oxygen and count up its electrons. They're sharing electrons, so I'm going to draw the circle around these 4 electrons in the middle, 2 pairs that are shared, and count up 1, 2, 3, 4, 5, 6, 7, 8. So it has 6 valence electrons that are valence, but it feels like it has 8. Okay, so 8 electrons shared. Well, that's bad wording. 8 electrons total by sharing for each one. And that's covalent. Okay? Well, let's look at one that's a little bit more complicated. Let's look at N3, or nitrogen. Nitrogen is a triple bond. Triple bonds. So here we go. Nitrogen, and nitrogen happens to have 5 valence electrons. So 1, 2, 3, 4, 5. So there's the valence electrons for that nitrogen. I'm going to bond it onto another nitrogen. And this is going to be N2, nitrogen gas. This is the main component of the air that you breathe. Okay, you breathe in a little oxygen, but you breathe 78% of what you breathe in is nitrogen gas. So here it comes. Here's 1 valence, 2, 3, 4, 5. So this nitrogen has 5 electrons in its valence shell. It feels incomplete when it's alone. So here comes the bond. I'm going to draw a circle around this nitrogen and count it up. So 1, 2, 3, 4, 5, 6, 7, 8. This is a triple bond. It shares 6 electrons. Now I'll draw the circle around the other one just to add them up and make sure. This nitrogen feels like it has 8 as well. 1, 2, 3, 4, 5, 6, 7, 8. So it feels like 8. So it feels like it has a full outer shell of electrons when it's bonded together covalently. This is covalent because it is 2 nonmetals. 2 nonmetals. Okay? Does that make more sense now? Okay.